So you are learning physical and chemical change in school as well, huh? But you said that your teacher actually taught a bit fast, huh?
Yeah.
So learning objective, take note, you must distinguish between physical change and chemical change, right? So they are not the same. How do you actually identify them? What is the difference between them? You need to know, and we are covering this. Use word equation to write chemical reaction. So you're going to represent reaction with word equation. What is word equation? Is something like 3 + 2 = 5, that kind of thing. But we write it in signs, okay? Instead of the equal sign, we use arrow. We go through it later. Describe chemical change caused by heat. So you can see things like thermal decomposition. Thermal actually represents heat. I think this one you know. Thermal actually represents heat. Sherman is here. Good. We just started. Hi, Sherman. Sherman, we are doing this new topic. It's on physical and chemical change. All right. So if you have not done the worksheet, Sherman, we are going through the worksheet later together and do at the same time. Is it okay, Sherman?
Yes.
Then also need to describe chemical change caused by exposure to light. Okay, now one thing you can take note, okay, like photosynthesis and photography, right? These are changes caused by light. So it's quite easy to remember these two examples here, these two reactions here. Then describe chemical change caused by passing electric current through a substance. We are talking about electrolysis. Now, so there are two changes that scientists talk about. Okay, one is physical changes, the other one is chemical changes. So during physical change, there is actually no new product formed. Okay, the properties of whatever you are talking about remain the same. For example, this is water in liquid state, and then this is water in solid state, but they are still water. Okay, the property of water doesn't change. Okay, nothing new is formed. It's only the state that changes. And when state changes, we call it physical change. For chemical changes, yeah, look at this one. Okay, this is water molecule. Water molecule looks like Mickey Mouse kind of shape. Then it's changing into hydrogen peroxide. Totally different now. Okay, water is water, hydrogen peroxide is hydrogen peroxide. They are not the same. So this is where a new product is formed. The new product is hydrogen peroxide. What happens when we boil water? Okay, see, when we boil water, right, it's going to start boiling and then turn from liquid to gaseous state. So changes of state here, right, is a change when no new substance is formed. Okay, and then it is reversible. Like what you see in the diagram here, from gaseous state, okay, water can also convert back to the liquid state. That's when condensation happens. Okay, similarly, okay, you have solid ice melting to form liquid water. You can freeze it again, okay, solidify it, change it back to solid ice. So the change of state can happen, okay, it's reversible, okay, it's not that difficult. Other examples include cutting a piece of cloth. After you cut the cloth, it is still cloth. It's not like it's changed to a new substance. Only the appearance changed, right? But it is still cloth. Freezing water to make ice, or tearing pieces of paper, it is still the same substance we are talking about. It doesn't change paper into something else. Okay, look at this one. Okay, referring to chemical changes, now we have two different substances. This is sodium metal. This is chlorine gas. Yeah, so these two, when combined and we heat it, we form a new substance. Okay, so a chemical change is a change in which a new substance is formed. Now, this is sodium metal. This is chlorine gas. When the two combines by heating, we get sodium chloride. And what is sodium chloride? It is actually table salt, or the common salt that we eat all the time. Okay, we find this in the kitchen. Now, sodium metal is extremely dangerous. When you throw it in water, a big piece of it can cause an explosion. Chlorine gas is like used in bleach. So swimming pool sometimes has a funny smell, right? After they clean the pool, there's always this bleach smell. That is chlorine. That's the smell of chlorine. So these two, okay, if you consume chlorine or you consume bleach, you can die, right? Yeah, so these two substances seems like quite dangerous, but when we combine, a new substance is formed, sodium chloride, totally not harmful to us, right? Unless you take in big quantity, it can lead to high blood pressure. Okay, otherwise, table salt we eat every day. Okay, it is added into food to make it more tasty. Okay, it doesn't bring us that kind of harm. Now, chemical changes are irreversible. Okay, mostly irreversible. All right, so if you want to get back sodium and chlorine, it is very, very difficult, almost impossible. So a chemical change is also called a chemical reaction. We can represent chemical reaction with a word equation. So remember just now I wrote down the sodium, I wrote down chlorine, and then I have sodium chloride. Yeah, so this is the word equation I'm talking about. Okay, Jocelyn, just now I say 3 plus 2 equals 5, right? The equal sign is replaced by the arrow. Okay. Then another thing I want you to know, okay, anything before the arrow, anything that's before the arrow, we call them the reactants. So these are the things that we put together, allow them to react. Okay, after the reaction, you form, so arrow means form, products. Okay, so the products that are formed here will be found after the arrow. So reactants combine to form products. Important to know this. So sometimes we write something above the arrow, okay, to represent the condition. The condition required for the reaction to occur. In this case, it is heat. Can you see the heat here? Okay, so because this process can only happen if we heat it. So the condition or the factors required is written above the arrow. Now, so let's just try to do this, okay? Write word equations stating their condition, okay, for the following chemical reaction. Let me start off with this one first. So we have magnesium. Magnesium ribbon, okay, magnesium ribbon is like strips of the magnesium metal, not in pieces, but it's like a ribbon kind of thing in a strip. Okay, so magnesium reacts with oxygen. So word equation means I spell out the words. To form magnesium oxide. And then there is supposed to be certain condition, right? Burning is also like heating. So we can put down heat on top of the arrow. Okay, so this is the condition required. Magnesium plus oxygen, okay, to give me magnesium oxide. So far, so good. All right, so maybe I get you all to try these. Okay, you say in the presence, in the presence of water and oxygen in the air, iron combines with oxygen to form iron trioxide. Now, I want you to identify, firstly, the reactants. Can you tell me what are the reactants here? And then there is one product, and tell me what's the product. Type into the chat to let me know. What are the reactants here? In order to identify reactant, it is actually the things that combine together, right? The things that actually react together to form something new. So can you type in the chat? See whether you can identify what are reactants and then what are the products. Sherman, would you know? Sherman, you say magnesium oxide. Magnesium oxide is which one? It's actually product. Okay. You look at this statement again. Okay, maybe I bracket this one. Iron combines with oxygen to form. Remember the to form? Oh, okay. Yeah, okay. Just interesting. How do you actually do that? Presence of water. Not bad. Reactants, iron and oxygen. That's correct. Sorry. Reactants are iron and oxygen because it says iron combined with oxygen. Okay, Sherman can understand this part now? It says iron combined with oxygen. Combine also can be replaced by the word reacts. Iron reacts with oxygen to form iron trioxide. All right. So just now, you were telling me the magnesium oxide. Okay, this one is already over. Okay, this one is a product. We are talking about the second one. So we write down iron plus oxygen, right? So these are the reactants. And then how many products are there? Just one, right? I said. So which is the product? Which is the product? Iron trioxide. I think Jocelyn gave me the answer. Okay, and she interestingly can actually try to put the thing on top. So the condition required for this reaction to take place, it says presence of water and oxygen, right? Yes or no? So we can write down presence. Nothing wrong if you write down the whole thing of water and oxygen. Okay, Sherman, can see this part now? Give me a thumbs up if you understand. Sherman can, So the next one. Yeah, thank you. So we try this again. During photosynthesis, carbon dioxide reacts with water to form glucose and oxygen in the presence of sunlight. Yeah. So I can bracket out to make it clearer. Like carbon dioxide reacts with water to form. To form sounds like they should belong to the arrow, right? So this will be something like my equation. You can type into the chat to tell me your answer. Okay, and then this one is like the condition. So how do we write this? Identify the reactants first, then identify the products. Sherman, I also want you to try to type in